So this time we will talk about the find the quotient of the complex number. So look at this example. So A. So the question is 5 over I. Okay. So when you have this kind of fractional form or like division form, the one fact is that we don't write either the radical or imaginary number or complex number on the denominator. It's because at least we have the real number, especially rational number on denominator, so we can analyze easily. So in this case, we have I value on the denominator, so we cannot make any division. Therefore, we have to make this number as a rational number. Okay? So then now we have I here. So through the I square, I cube, and I fourth, we know this value becomes -1, this value becomes 1, right? Therefore, now the closest rational number is -1. So we want to make I as -1. It means we need to make I to I square. How to make I square from the I? If you think multiply I, that is correct. But when you multiply, then you must multiply I both on numerator and denominator, so that I over I equal to 1, so simply nothing happened. Okay? Then this becomes 5I over I square. We know I square equal to -1, so the answer becomes 5I over -1, or we can write -5I. That should be the answer for this problem. Okay, then let's look at one more question. So this time we have complex number form on numerator, but denominator just 5I like that. Okay, so again, we don't care numerator. Numerator can be any numbers, but not the denominator. Denominator must be rational number, not even radical either. Okay, then now, so the closest rational number from 5I will be -5. Now how to make -5? Yes, we just make I square. Then that will be easiest way to do it, right? Therefore, you may think, why not we multiply 5I again? But simply you can just multiply I. I may show you multiply 5I maybe after this and then see what's gonna happen. But simply we can multiply I both on numerator and denominator. Okay, don't forget you distribute, and this becomes 3I minus 2I square over 5I square. So we know I square equal to -1, so I'm going to replace all the I square value. Then this becomes 3I minus 2 times -1 over 5 times -1. So it means 3I plus 2 over -5. So simply that's the answer, but we want to make it as the complex number form, which means we can make this first. So 2 over -5 plus 3I over -5, so that now you can simplify this one as -2 over 5 minus 3 over 5I. That will be the answer. Okay, now I'm going to show you what happened. We just multiply 5I from here. Okay, so So 3 minus 2i over 5i, and then we multiply 5i both on numerator and denominator. Then this expression becomes 15i minus 10i squared over 25i squared. Therefore, (15i minus 10 times negative 1 over 25 times negative 1, which is 15i. So 15i plus 10 over negative 25. Now then you need to make same thing happen here. So negative 10 over 25 minus 15i over 25, and you have to simplify. Then eventually you will get this answer here. Okay, then there's nothing wrong to multiply 5i here, but as you see, number get bigger and then later you must simplify. However, if you know which to multiply I here simply, then your calculation can be much more simpler. Okay? So let's talk about two more questions. Let us see. So 3 over 5 minus 2i. Unlike previous two questions, now the denominator we have a complex form. So even though you multiply I on denominator, we still have I because 5 times I become 5i. So we cannot just multiply I. Then what can we do? What do we do? Then the denominator becomes the rational form. The key point is conjugate factoring. So you multiply conjugate number, then we know the property a plus b times a minus b equal to a squared minus b squared, and then the number of this item will be eliminated. We checked it from the previous example, right? Okay, therefore we just multiply conjugate of the denominator expression, which is 5 plus 2i. So when you do it, you must multiply both the numerator and the denominator. Otherwise, the expression will be ruined. Okay, be careful. Now, the numerator, you have to distribute and find their multiplication. So this becomes 15 plus 6i. Now, denominator, we know the property. If we conjugate, then the first factor square minus the second factor square. So I'm gonna make 5 squared minus 2i squared. Therefore, this becomes 15 plus 6i over 25 minus 4i squared. Now look here. I squared is negative 1, which means the rational number. So we can simplify this one. 15 plus 6i over 25 plus 4. Therefore, the answer becomes 15. So 15 plus 6i over 29 here. So just making complex form, number form, then become 15 over 29 plus 6 over 29i. Of course, if we can simplify, then you better do it, but since 29 is a prime number, so we cannot simplify. So that should be the answer for this division problem. Now, look at this problem. Now, both the numerator and denominator, we have complex form, but we don't care the numerator. We only care the denominator and then focus on them make on the rational form. So now same thing, we multiply conjugate. What's the conjugate of 5 minus 6i? Yes, if you think 5 plus 6i, that is the right conjugate of this expression. So we multiply both the numerator and the denominator. So nothing happened basically, right? Now, both numerator and denominator require FOIL method to expand the expression. So let's do so. Then this becomes 15 plus 18i plus 35i plus 42i squared over, now conjugate, again, conjugate case, it can be the first factor square minus second factor square. So I can do 5 squared minus 6i squared. So this becomes 15 plus 53i minus 42. Why? Because I squared becomes negative 1. Then over 25 plus 36, because this will be 36i squared, and then I squared becomes negative 1. That's why I can make plus 36. Now we'll combine like that one more time. Then this becomes negative 27 plus 53i over 61. Okay. Now, if we just make a complex number form, then this becomes negative 27 over 61 plus 53i over 61. That should be the answer for this division.